Dr. Hovind, I love your doctoral thesis. I've torn it to pieces with house and gaffle. I can't remember when I last pissed myself laughing. It's a good thing the thesis mopped the piss off the floor.
Welcome to part 6 of this read-through and peer review of Kent Hovind's doctoral dissertation, which was published on wikileaks.org on December the 9th, 2009. If you have not yet seen the first parts in this series, then I recommend that you go back and see those first, as in this episode, I will be starting off exactly where I finished off in the last. In the last episode, Kent gave us various different proofs for the age of the Earth. Unfortunately, these were either based on obsolete theories and obsolete models of the interior of the Earth, or creationist maths, i.e. maths that's wrong. But anyhow, back over to Kent. If we can prove that the Earth is young, only 6,000 or 7,000 years old, that really ends the argument of evolution. Yes, Kent, it does. I'll have to agree to that. It absolutely ends it. Stone dead, flat, gone. The only problem is, Kent, is that you can't prove that the Earth is 6, maybe 7,000 years old. All of the data indicates that the Earth is 4.345 billion years old. All of it, Kent. I mean, all the studies carried out using modern models of the Earth, modern scientific data, modern scientific theories, and not the obsolete crap that you keep digging out from 1850 and then some. All the crap cranked out by the Institute for Creation Research, which has about as much scientific credibility as Scooby-Doo. But anyhow, evolutionists will fight tooth and nail to be able to hold to the faulty idea that the Earth is billions and billions of years old. What, Kent? That faulty idea is supported by all the evidence, whereas your scientifically accurate assertions are only supported by an old dusty book written by desert nomads who herded goats, and believe that curing leprosy could be achieved by killing a bird. I think what you're finding, Kent, is that these scientists are telling you that you're completely detached from reality. That's because you are. When a number of scientific attempts to establish some kind of age for the Earth prove that the Earth is really very young, reasonable people should accept the facts. Yes, Kent. And when these scientific attempts to establish the age of the Earth that prove that it's really young are found to be based on faulty notions, obsolete data, and faulty mathematical calculations and figures, then reasonable people should accept that those results are bollocks. But anyhow, of course, evolutionists would jump at anything that would indicate that the Earth is billions and billions of years old, because it is such a vital part of their theory. Yes, Kent, and the avalanche of evidence that backs up these evolutionary ideas is overwhelming, to say the least. Unlike the avalanche of bullshit that you spout, which just stinks. I digress. Carry on, Kent. Someone would say, what about the stars? We know that they are billions of light years away. Not all of them, Kent. Just some of them. Some of our stellar neighbours are actually quite close. For instance, Proxima Centauri is only 4.2 light years away from our Sun, and Alpha Centauri is only a little under 4.4 light years away. But I won't let that piss on your parade. Carry on. I don't want to sound like a crackpot, but actually we don't know that stars are billions of years away. No, I didn't miss the word light out there. Kent really did say billions of years away. But hey, we can't keep a good man down. The nearest star will be billions of years away if you're walking there. But carry on, Kent. There are 2, maybe 3 methods of determining how far away the stars are. Yes, Kent, and they're actually quite accurate. But carry on. One of these methods is just simple trigonometry. Yes, Kent, it's done using a thing called parallax. You observe the star and note down its relative position in relation to the other stars in that field when you are at one side of the orbit around the Sun. Then, 6 months later, you do the same again when you are at the other side of the orbit of the Sun. You then compare the two, and using simple trigonometry you can work out its distance. But do carry on. However, when you get to extremely minute angles, it is very difficult to measure anything less than a couple of arcseconds accurately. You cannot measure distances accurately more than 60 to 100 light years away. Not 60 to 100 billion light years, just 60 to 100 light years. Yes, Kent, that's why that method is only really used on stars that are relatively close by. But do tell us more. The other method that is used is called the redshift method. We will discuss this method in detail later. Well, Kent, as I've already read through the remaining 10 pages of your thesis, I know that you don't. So I'm going to take this opportunity to discuss this method now. The redshift method is based on the observation that the universe is expanding, and that everything is getting further away from everything else. This is the basis for the Big Bang Theory, in that when you run the model backwards, at some point, around about 13 to 14 billion years ago, everything ends up in the same place. Anyhow, let's take an object, a star that's maybe 1 billion light years away, 1 billion years ago. Light from this star travels at the speed of light towards Earth. Now, during the 1 billion years that it has been travelling towards Earth, the universe has expanded, and therefore the distance in space-time between that star and the Earth has increased. And as it increases, it stretches the wavelength of the light beam, shifting the frequency of the light towards the red end of the spectrum, through red into infrared for some of the more distant objects. The more distant the object is, then the further the light has had to travel, and the longer the light has had to travel, and therefore the more shifted towards the red end of the spectrum the light appears when it reaches the Earth. The shift can be determined by observing the emission spectrum of that particular star. Elements within stars will cause these lights to have a particular emission spectrum. An emission spectrum looks a little like a barcode, and when scientists compare this emission spectrum with light from, say, our Sun, we can determine how far to the red end of the spectrum the light has been shifted. It really is quite accurate, especially when considering the great distances that are concerned. We presume that Kent is leaving it out of his thesis because it utterly destroys the notion that the universe is 6,000 years old.